Welcome to Shrav's Boost Beast Websocket server, session 2. In the first session, we have discussed the multi-chat application and the changes that were made on top of that example. So in the first example, we implemented the WebSocket-based stock code stream publisher. So the codes are read from the Redis topic and published over the WebSockets to the client. In this session, we have enhanced that example to use JSON token authentication and also subscription to specific symbols. So let's go through a quick demo. I updated the example. So in the WebSocket client, now we added a new parameter called API token. So if there's only a valid API token, only then we can connect to the server. So for now, we have a valid token here. If I open the connection, it should open. Now if I close the connection and then give an invalid JSON web socket, JSON web token and try to open, the connection will be immediately closed. So it's closed. So that is the change we made in this session. And then we also made the request conversational. So we can pass a string in this format, type and topic. The type could be 1 or 2, 1 implying subscribe, 2 implying unsubscribe, and then we give a list of topics that needs to be subscribed to. So for example, let's subscribe to both Bitcoin USD and Ethereum USD. We send a message. So the server is running on a single Docker container, so it takes a while for these code streams to be published. So in the meantime, we'll go to the other screen. We'll clear this. So in this screen, if you see here, we were subscribed to Ethereum USD only, and then type is equal to 1, and we were getting codes for the Ethereum USD only. So now on the other screen, yeah, we are subscribed to both Bitcoin USD and Ethereum USD, and we can see the codes being sent for Bitcoin USD and Ethereum USD. It's scrolling too fast, but yeah, let's actually unsubscribe, send. So we sent unsubscribe, so we stopped the subscription. If you see here, we got both Bitcoin USD and there should be Ethereum USD somewhere. Ethereum USD. So if you see here, there's Ethereum USD. So these are the changes we made in this session. Also, the changes that were implemented to subscribe to specific symbols is complex. So I'll break it down the discussion into two parts. In today's session, we'll only cover around 50% of the changes. In part 2, we'll discuss the rest. And in part 2, we will also update this architecture diagram because there are some things which we added new and not reflected in this architecture diagram. So let's go through the code. So to make it more easy to understand, we're going to go through the Git graph in VS Code to just see the changes that were made on top of the previous session. So we'll cover some files today and the rest of the files we'll cover in the next session. So these are the utility include headers which we have not done much, so we will skip them. So we made change to the http session.cpp class file. If you recall from the session 1, HTTP session class is the entry point. Once a WebSocket connection comes through, it is this class which will determine if it is a basic HTTP connection or a WebSocket connection. And based on that, it will either pass the request to the WebSocket session or passes it within this class and sends the REST API response or HTTP response. So that logic is here, which we discussed in session 2. So once you get the on read on the socket At line 254, you check if it is an upgrade request. Parser.get sends a reference to the request body. And if it is upgrade, then we send the request to a WebSocket session. A release will give you a R value. It's a constant. It cannot be modified. So we have finalized the request, and we send it to the WebSocket session, or we go through the rest of the logic and we parse it as a HTTP session, and then we handle the request. So before we do this part, we added a validate JSON token logic there. So I'll push this to the left. So validate JSON token will take a reference to the request object, request body, and then uses CPP JSON web token library, which I mentioned in the documentation. So it will get the request, and from the request it will get the URL. Then using Boost Beast URL, we parse it, get the parameters, and see if there is an API token parameter. If we have that API token parameter, we parse it. So the JSON web token I showed in the example is encoded with this secret. So we have to decode with the same secret. If we are able to decode, we send boost none, else we do the rest of the logic. And in the calling part, since we send boost optional message generator, and if it's a valid token, we send boost none. So if this method sends an unauthorized response, we do the if condition. We say it's sending unauthorized response, and we send unauthorized response, and when we send the HTTP response on a WebSocket closes automatically. So we're just using that framework. Else we let the program go through, and then we parse the request and serve the WebSocket request. So that is the JSON Web Token authentication. Now we'll go through the other files. So we discussed the HTTP session. Then we implemented a class called parser.cpp. Parser.cpp will get the message from the WebSocket. In this case, this one. It will get this as a string. It will parse it. And sends an key value pair using Boost JSON. So that's the change. That's the new class we added. Now parser.cpp is used by WebSocket sessions.cpp. So we added this session. This parser is created in the shade state. If you look at the architecture, we have a shade state. In the shade state is shaded by these various components: Redis subscriber, Redis publisher, and then the WebSockets reside in the shade state. So now using shade state, we get the parser instance, and then we pass the data we got over the WebSocket, which is that JSON string in the WebSocket client I showed, and then it sends itself, the WebSocket itself, to that function. So that's the only change we made in the WebSocket sessions. Now once we get to the WebSocket sessions, in the shade state.cpp, we have a parser, the parse method, which gets the message and the WebSocket session. And then since it's a message, parser.parse we get the object key value pair, which is in the parser.cpp class we just discussed. And then we see what is the type of the message. Is it subscribe, unsubscribe? Message type is an enum class with subscribed assigned 1 and unsubscribed assigned 2. Based on that, the topics are comma separated list, comma separated string. So we get a vector of those topics and we pass it to these two methods. WebSocket subscribe to symbol, WebSocket unsubscribe to symbol. So the WebSocket would subscribe to symbols or it will unsubscribe from symbols based on the message we sent. So this is where the conversation happens. The message is parsed and accordingly functions are called. In future, we will enhance this parser to make it more feature rich, more conversational. Now, in the shade state.cpp, the change that were made in shade state.cpp, first we get the list of topics and as the parameters to the main.cpp. So we are letting the server know that these are the WebSockets we will serve. So those topics are sent as a comma separated list. So we parse them and then create these symbols, unordered map, an unordered map of topic, which is a string, and shade pointer of symbol. So we have n symbols, shade pointers, which are all unordered map. So that is what we are doing here. And then we just discussed WebSocket subscribe to symbols and WebSocket unsubscribe to symbols. So in the meantime, you could go through the code, but to make it more easy to understand, I have to update the architecture diagram. So we will skip the rest of the discussion to the part 2, which will be in session 3. Now we'll close this and we'll go back to the publisher.cpp. Now the publisher is the program or the thread. WebSocket publisher is the thread which will send the messages over the WebSockets to the client. Now this is a minor change, so I'll discuss this in this session in part 1. We have updated the single producer single queue, which is here, single producer single queue. Redis subscriber sends the message over this queue to the WebSocket publisher, and the WebSocket publisher, using the shade state, will send the messages to the WebSockets. Now I updated that message from the string format into std pair, and the std pair will have a string and the message string from the topic std pair 0 and get 1 is the message itself. From the topic, right? From the topic, we will, in the shade state, we have unordered map of topic and symbol shade pointer. So using the topic string, we get that symbol's shade pointer, and then we log that mutex, and then we'll send the message. This is the original code. Same, we just removed the print statements and the rest is the original code. And that's how we are getting the access to the WebSocket list of WebSockets which are interested in the code for this symbol. Now the rest of the changes will be discussed in the part 2. In the meantime, I would suggest go through the whole code base. I have already added to the gist here. So please go through that, and the whole code is there. And stay tuned for the session 2. Stay tuned for the session 3, where we will discuss the part 2 of the changes made here. And as I already mentioned, mentioned that part 2 would require updates to the architecture diagram. I will update the architecture diagram and then discuss the rest of the files that were changed. So we will continue the discussion on publisher.cpp, shade state.cpp, and subscriber.cpp, and also symbol.cpp. So these 4 files would be discussed in the part 2. Thank you for watching.